See, this is our AC generator. What we have and how it works. See, in AC generator, we have a coil. This coil is armature coil. This is your armature coil. This coil is your armature coil. Okay, I'll highlight it with black one. This is your armature coil. Yes, this is your armature coil. And that armature coil is kept between north and south pole of the magnet. That armature coil is connected to slip rings. This is slip rings. Okay, and that slip rings is then connected to carbon brushes. And that carbon brushes are then connected to what? They are then connected to the source. Here there will be a source. Source means anything. There can be a bulb, there can be a galvanometer, anything. Okay, so we have armature coil. That armature coil is connected to slip rings. What is the purpose of slip ring? To maintain continuous contact. See, slip rings are like this. To maintain the continuous contact with the armature coil, we are using the slip rings to maintain the continuous contact. Okay, that slip ring is connected to carbon brushes. Slip rings are copper, it will be connected to carbon brushes. See, because entire time that armature coil will be connected to our slip rings. So it will be continuously in contact. So it will be collecting area. There will be a collection of induced EMF here. There will be induced EMF. Then what that by means of carbon brushes, it will be sent to the source. How this will work? From north to south pole, we know that from north to south pole, there will be from north to south pole, there will be magnetic field lines, right? There will be magnetic field line. Not like this. Yes, it will be straight like this. There will be a field line. Okay, when this will start motion, this armature coil, there will be a cut in the flux. That means there will be a change in the flux, and whenever there is a change in the flux, there will be what? There will be induced EMF, and that induced EMF is connected to slip rings, and that slip ring is connected to carbon brushes. That carbon brushes are connected to what? That will be connected to the source. This is how AC generator works. Now, how can we rotate this thing that will study in AC circuit? How to rotate this armature coil? But you understand the concept? Yes. When this will be rotated, there will be cut in the flux, and when there will be a cut in the flux, there will be production of EMF, and that production of EMF is responsible for there will be change in flux. The change in flux will be responsible for production of induced EMF. Okay, so this is how our AC generator works. Now what? Now we have a small derivation for it. See, we have a derivation of AC generator. Let me check the derivation for it. This is the last topic. Okay, yeah, I'll give you the derivation. See, we know that E is equal to d phi by dt. But what is phi? Phi is equal to BA. Okay, BA cos theta. If there are number of turns, we can use NBA cos theta. So therefore, your phi will be equal to what? The phi will be equal to NBA cos theta. We have to find E. E means induced EMF. So we know that induced EMF is nothing but nothing but N B A, sorry, once more, see what we have phi. What is phi? What is phi? Phi is equal to N B A cos theta, right? Yes. In place of cos theta, in place of not cos theta, in place of theta, we can write omega t. We have to find E now. So here E will be equal to d phi by dt. What is d phi by dt? That will be equal to d upon dt of, what is phi? Phi will be NBA cos omega t. So this NBA will come out of the picture and you will use the d by dt of cos omega t. What is cos theta? What is the derivative of cos theta? Yes, minus sine theta. So this will be equal to what? NBA. In derivative of cos theta will be sine omega t and derivative of omega t will be omega. So this will be equal to NBA omega sine omega t. Okay, yes, you will take minus sign outside. Or else if you would have take minus sign here only starting by Lenz law, so you could have got the value as plus here. So this is how your E is will be equal to NBA omega sine omega t. By comparing it with standard equation, that is E is equal to E naught sine omega t, you will get this E naught value as what? NBA omega. And you will get that this induced EMF is performing sine omega t is there in the picture. We have already studied in the oscillation. If there will be a sine function, that means it will perform the sinusoidal curve, sinusoidal sine wave. Okay, yes. So this will perform a sinusoidal sine wave like this. You just substitute the value in E is equal to E naught sine omega 0, 90, 180. You will get this curve. You will get this curve. You will get this curve. Okay, so this is how the curves come into the picture. Let's see some question based on this. The questions are, what specific component in an AC generator facilitates the conversion of mechanical energy into electrical energy? What converts mechanical into electrical energy? Stator, rotor, commutator, armature. Armature coil. Okay, mechanical energy. Motion, it will convert into electromotive force. Then we have, what term characterizes the highest voltage produced in an AC generator? Highest peak, not average, not RMS, but peak will represent the highest voltage.